my name is João Freitas, and today I'm going to talk about fairness, bias, and ethics in AI. I'm a CTO at DefineCrowd. DefineCrowd is a data provider, and so we're going to focus our presentation precisely on that. How can data influence these three parameters for AI? So when we think about submitting a paper, and when I was doing my PhD, I often went to PhD Comics website that is quite familiar for a lot of people. And when you submit a paper, it's hard to tell how many references are a good amount. And so this comic jokes a bit about that. And uh, understanding what is enough depends on someone's opinion, depends on if the person that is judging or reading your paper actually has the same opinion or the same follows the same guidelines as you do. And so this is to introduce the concept of how fair can be a review or how fair actually a machine learning model can be. And fairness is something that we use, it's a social concept. So it's something that it's individual. It's based on an individual perception. It's based on a context, and it changes this concept. This individual perception changes also from region to region, from culture to culture, and it is something that we shaped since we are educated and grow. While when we talk about bias, bias is, and here specifically in this presentation, we look at bias from the mathematical concept, the part that is applicable to machine learning and how can bias influence our machine learning models and specifically our AI system. As for ethics, when we speak about ethics, it's something, it's a platform where we use as a systemization of what is right or wrong. It's a normative concept, and it's also something that we need to account when developing our AI systems. So, and then why are all these concepts connected? Well, there's a couple of things that we can do, right? We can use bias to compensate for fairness, but this is just an example that we'll go through this presentation. So fairness in AI is something, it's a concept where when we think that the system acts based on domain specific data, and it's a system that is fair. It's a system that has comparable performance across distinct classes. So a fair system that does not benefit, for example, one ethnicity over the other, or a young person over an old person, is a system that is fair, and that's what we call fairness. So a system that has the same performance regardless of its user base and regardless of the classes that we're trying to classify. And usually when we speak about the fairness in AI, we can look at the features and the algorithms. So, and we should not use, for example, things like gender, race, age, religions in order to feed as features of our models, because then we'll be creating models that make decisions based on these features that might not be fair. And so there's a part of fairness that looks at features and algorithms, and there's another part of fairness in AI that looks at our data sets, which is the second part I talked before. And so some examples of unfairness in AI include systems that work very well with some ethnicities. So, for example, people with a brighter skin tone will have good performance, and maybe people with a darker skin tone will not be able to use the system. Or, for example, faces that from certain regions with certain characteristics of certain regions will have a better performance, and so that creates an unfair system. There's also these correlations that often systems do that are quite unfair. For example, when we always choose one group over the other just because that group is more frequent. So if we have a job candidate screening, which is the example I give here, and we are always selecting male candidates, and then we discard female candidates just because the male are more frequent. So this is another example of unfairness. And then we have a lot of examples in customer service where systems start to learn offensive words by the interaction with the users, where they don't understand certain dialects, certain accents, or certain expressions that are characteristics of regions or of certain population groups. And so this is something that we need to account when we develop our AI system, and it happens in several stages of development of AI system. So if we look at the end to end, so from defining what is the goal of our AI model to going through the collection, preparing the data, training the model, and then testing that model, there's several stages where we can introduce unfairness. And when we introduce unfairness at an early stage, like for example, after the data collection and annotation, it's really hard to detect this unfairness when we reach this testing stage of the model. And one of the things that we need to be careful is that unfairness propagates across this flow. So when we define the our goals for the model, we need to understand the problem as a whole. We need to understand what are the ideal distributions, how, for example, do we model our data in order to avoid that the generalization that is usually associated to the models in order to have better performance don't create unfair results. And then when we're testing the model, how can we be a little more fair in our test in order to encompass for all the groups? So, and that leads us to bias. And when we think of bias, is often also can happen in our algorithms, but here we'll focus the conversation on data bias. And very simply, AI is a combination of learning algorithms and data, and many times we use data from real world. And what happens is that if that data is already perpetuating some bias that happens systemically in our society, we're introducing that bias in the model. So we're basically generating incorrect or inaccurate results that can damage, for example, a brand. And we call this fairness by ignorance, which is a model doesn't know that he's making unfair decisions or making biased decisions because we haven't explicitly went and annotate that data. The model just makes the decisions. So how can we be a little bit more aware of this, because many times we make these decisions because we want to be faster to the market, so we introduce this data bias. One approach in order for this to be more scalable is to use approaches like crowdsourcing, but we also need to be aware that crowdsourcing, although it can lead to less bias because I have a way to use crowd that, for example, is spread all over the world or multiple locations, this can also be hard to control. So with crowdsourcing, we are able to get more information about who is contributing to our data. When we collect the data, who are the agents that are contributing? And there's multiple ways that we can control quality in terms of the data that we're collecting, either at the contribution stage, either at the data quality stage, or at the task level. All of these towards having more bias. And then we look at ethics. And one of the things that is often raised in crowdsourcing is that it can be questionable if all crowdsourcing platforms and if all the crowdsourcing approaches that we have nowadays are really ethical, and it's something that we want our children to participate. So if we think about the PAPA framework that was introduced in '86, this still is so much up to date nowadays. We need to think about privacy of the people that are giving the information, about how accurate and reliable is the information that they provide, and what are their rights and how can they access the platform or the environment that influences the data that they provide. We'll focus on the last two in this presentation. And so in terms of ethics, the the um, the, the crowd is the collective good. But for example, you have platforms that in order to reach a decent payment, you need to go through a lot of tasks, to do a lot of tasks in order to access tasks that already give you a decent payment. So that is unfair because you don't have immediately access to a fair payment. You need to go through an unfair process in order to get to the fair process. And this is what we need to be very careful when we're collecting data. Another aspect which is really important is accessibility. And we can collect data based on crowdsourcing, but we want to ensure that we have a uniform distribution of data in order to solve our problem. And many times we look at variables like gender, but this gender is not factual. Gender is a social stereotype that we introduced as society. But the fact that we are collecting data and saying that we have a distribution, an even distribution of 50% male and 50% female is not factual because the voice is based on characteristics like the pitch, and so I can have a male speaker with a female voice and vice versa. The same goes for ethnicity. So if I'm using ethnicity, I can. It doesn't mean that someone that is Afro-American can have a certain skin tone. So instead of using things that are social stereotypes, we can test our performance by using more factual information in order to ensure more uniform distributions. Of course, this is also this gives you a more transparent distribution. So you're building your model based on more transparent and factual information instead of using social stereotypes that many times are not correct and that actually introduce bias. So to wrap up, we spoke about three things. We spoke about how can we have a more fair approach in order to build our models? How can we ensure that our models take into account real world issues and that the fact that we have a tight time to market is not going to create unfairness? And how can we make sure that when we test our models, we're testing for all the things that are fair? We need to be very careful also to not introduce bias in our data, and we can use, for example, crowdsourcing as an alternative to address that, as long as we always provide fair payments and having in consideration things like privacy. And then we want to promote also an ethical data ecosystem that we can use in order to build our systems. Thank you for listening. If you have any questions, feel free to email me at joão@definecrowd.com. And it was a pleasure to be presenting at Building the Future.